Hey everyone, in this video we're going to look at integration of circular functions. So I'm just going to scroll up and show you the derivatives of circular functions. So remember, antidifferentiation is basically just the opposite of differentiation. So if you can kind of understand the derivatives of circular functions, then the antiderivatives aren't really that hard. Do remember that it's extremely important that you remember your exact values off by heart. Okay, so we've gone through this in quite a lot of detail. I've taught you how to draw the table of values or to draw your triangles just to remember what they are. So it's extremely important that you remember them. Now, even though I've taught exact values for trig for many years, I still struggle to remember them. So there's some that I do recall, and I guess if I was put on the spot and I had maybe 5 minutes thinking time, I could probably think about what it would be. But in an exam situation, you don't have that luxury. So please make sure prior to your exams that you take the time to know the exact values off by heart. Anyway, let's make a start. So you can see up the top our section summary, you've got the antiderivative of sine and the antiderivative of cos. No need to do the antiderivative of tan. All right, so it's just sine and cos. I've also put there the exact values mostly for my own benefit because, as I said before, I'd probably need some thinking time. So just to kind of speed things along, I've just put the exact values there again. Okay, so in question 2, what we're going to do, just like we've been doing with any definite integrals, we're going to find the antiderivative and then substitute in our value of b and then subtract the substitution of a. All right, so you can see we've got a whole mix of questions there. Obviously, I'm not going to do every single one because we don't want this video to take on forever. Oops, just dropped my pen. And then we're going to do a few harder ones. And then question 6, we're going to look at sketching and then the area, etc., etc. So with, I guess, exam type questions, this obviously would be an exam 1 where you can't use your calculator, but please make sure that you can do things like sketching a trig function, okay, that you know your exact values, because I don't think that the calculus part for this topic is going to be that hard, okay? So it's probably more the understanding what a trig function looks like and also your exact values. That might be the hard part. Kind of like the fractions and negatives that might get you when we did other types of definite integrals. All right, let's make a start. So a 3-minute introduction when we could have made a start. All right, so the first question we've got, we're finding the definite integral of, so we've got to find the antiderivative of sine x, and we're going from 0 to pi on 4. Now remember, this is asking for the definite integral. It's not asking for an area. So it's extremely important that if you're just finding a definite integral, it can be negative. Okay, it doesn't have to be positive. It's only when you're finding an area that it has to be negative. Okay, let's go ahead, get our pen ready. Okay, I'll just do it over here so we can see everything. So we're going from 0 to pi on 4, and our function is sine x dx. So don't forget your dx on the end. All right, so set up my square bracket. Now the antiderivative of sine x is negative 1 on k cos kx. Now, k being the coefficient of x, now there is no coefficient, well, the coefficient of x is 1. So it's going to be minus 1 on 1, which is just 1. So it's just minus cos x, and then that plus a would be if we had a constant. We're adding a constant to x, but we're not. So that's all it is. So 0 to pi on 4. Now it is negative cos, so just be careful that you don't forget the negative. You can take the negative out as a common factor if you like, but I'm just going to leave it there. Actually, I'm going to take it out. All right, so I'm going to take the negative out, and then we've got cos pi on 4 minus cos of 0. All right, so cos pi on 4, let's find it on our table. So there it is, 2 root 2, and cos of 0 is 1. Root 2 on 2 minus 1. Okay, so we're going to leave it in exact form. So if we're adding or subtracting fractions, obviously we need the same denominator. I'm going to keep that negative out the front, and then we're going to add 2 on 2. No, we're not. We're going to subtract. I'm getting ahead of myself. So that's going to become negative root 2 minus 2 all on 2. And that negative is, multiplying both the root 2 and that 2, so I should put a plus there. So we've got 2 minus root 2 on 2. My year 10s, and I don't think you guys do it, often would cancel them out. They don't cancel, so don't make that mistake. It's just 2 minus root 2 on 2. Now let's just double check on the calculator. All right, so I just want to have a little bit of practice using the calculator as well. So we're going from 0 to pi on 4. Now remember, we're in radian mode, so just make sure your calculator is in radians. So we want rad, and we're just doing sine x and dx. All right, so what it's actually done, instead of putting everything over the same fraction, you can see it's just kept it as we did here. All right, so it's exactly the same thing. I just put it over the same fraction. All right, let's choose a different one. I'm going to choose a hard one. Let's go on to maybe doing f. All right, so we're going from 0 to pi on 3 cos 3 theta plus sine 3 theta d theta. So your variable is theta. Remember, theta is just like any letter. All right, so previous questions we've been using x. Theta is just a letter. Okay, so it's just a pronumeral like x, like t. Doesn't always have to be used for an angle. Okay, it's just, usually used in trigonometry, but it is just like x or t. All right, so let's go ahead and find the antiderivative. So you can split it up if you want to. I'm not going to, although I might change my mind as we move through. Okay, so the antiderivative of cos becomes sine, and we do have a coefficient in this one, so it's going to be 1 over 3 sine 3 theta. Now make sure you write theta, not x. If you did that in an exam, it would be marked incorrect, unfortunately. All right, and then minus sine, sine becomes minus 1 on 3 cos 3 theta. Oops. And we're going from 0 to pi on 3. So we're going to substitute in pi on 3 first. All right, so sine pi on 3, where are you? Root 3 on 2. Okay, so 1/3 times sine 3 pi. Oops. Actually, I just realized I made a mistake. Do my substitution first. Sorry, that was me working ahead. All right, 1/3 sine, now theta, 3 times pi on 3 minus 1/3. Oh, I'm not going to have enough space. Actually, I'll just go over the next line. 1/3 cos 3 times pi on 3. And then we're going to subtract, so the substitution of 0. So 1/3 sine 3 times 0 is 0. And then we've got a minus there, so I'll do that actually. 1/3 sine, cos 0. And why did I have square brackets there? Just checking everything's right. So just substituting in pi on 3, then 0, then 0. Make sure my negatives is okay. All right, so now these 3's cancel out and we're doing sine pi. So going up to your exact values. Pi isn't on there, but I know that sine pi is 0. Where are we? Start down here. So 1/3 times 0 is 0. Then cos 0, cos pi is -1. So we're going to have minus 1/3 times -1. Right, so we're up to here. I feel like I'm a little bit lost. All right, so cos of pi is -1. All right, and then we've got minus 1/3 sine 0. So sine 0 is 0. Minus 1/3 of cos 0, which is 1. All right, so just be careful with your negatives. So now we've got -1/3 times -1 gives you positive 1/3. And then we've got minus -1/3 times 1 is going to be -1/3. So we've got minus and a minus. So it's going to be 1/3 plus 1/3. So we get 2/3. All right, so let's do this on the calculator. So 0 to pi on 3. And we've got cos. Now you can do theta. I don't think, oh, there we go. Theta is actually there. Plus sine 3 theta. And then we just make sure we do d theta. Now, if you want to use x, that's fine. Just make sure when you write any answer, it has theta, not x in the answer. Okay, and then we go 2/3. So that question there, not too difficult, although I should have probably written it longer so it wasn't all jumbled up. That's what confused me a little bit. But the negatives, just be careful with your negatives and obviously knowing your exact values. Now, I know in my little table here, we didn't have pi, but when I was working out the exact values, I was actually picturing the graph in my head. So I know a cos graph starts at 1 and then goes down and at pi gets to -1. And then your sine graph starts at 0. So that's how I remember some exact values as well. So picturing the graph. All right, so I'm not going to, actually we should do I. Let's do I over the page. So just move this one down. This is going to be quite a long video compared to what I've done recently. Sorry guys. Oops. What are we doing? Just wanted to go on to the next page. Okay. Okay, so we're going from 0 to pi on 4, and we've got sine 2x minus pi on 3, and our variable is x, so we're going to do dx, and I just make sure I put that in correctly. All right, so first of all, finding the antiderivative. So you can see here, all right, we've got a value of k, and we also have a constant there. So just take that into consideration. So we're going to have -1 on 2 cos and then just 2x minus pi on 3. Whoops. And then we're going from pi on 4 and 0. Okay, make that a bit bigger so we can see it. Oh, I did write very large then. Okay, so substituting in pi on 4. So we've got negative 1 on 2 cos 2 times pi on 4 minus pi on 3. Don't worry about that for now. Let's just do the substitution because I can see there's a fraction there. Then we've got minus negative half cos 2 times 0 minus pi on 3. So we just need to tidy that up a little bit. All right, so we're going to have 2 pi on 4, which is pi on 2, minus pi on 3. And then the two negatives makes that a positive. And then 2 times 0 is 0, so we're going to have minus pi on 3. All right, now this part here, instead of writing it again, I'm just going to just do this part. All right, so we're going to have both fractions over 6, so that's going to give us pi on 6. All right, and then negative pi on 3. All right, so got negative a half times cos pi on 6. Now I'm going to have to just scroll that. Cos pi on 6 root 3 on 2. And now we've got plus a half times, now cos of negative pi on 3. Now think of your unit circle. So we're actually in this quadrant here. So, all right, so all positive, sine positive, tan positive, and cos positive. So in this fourth quadrant, cos is actually positive. So this angle, cos negative pi on 3, is the same as cos pi on 3. So I might just write that here. So going up, cos pi on 3, where are you? So that's going to be 1/2. All right, so we're going to have negative root 3 on 4. So when you're multiplying fractions, you multiply your numerators and multiply your denominators. And then we're going to have plus 1/4, and you can put them on the same denominator like so. All right, let's just do this one on the calculator as well. I like to just check it, so you can skip ahead if you like. 0 pi on 4 sine 2x minus pi on 3 dx. And you can see they've just separated the denominators, separated the fractions, but we put everything over the same denominator, so same thing. All right, let's move on to question 5. So I'm just wondering if that's really that difficult. Let's just do D. Otherwise this video is going to go on forever. 5D. Oh, I probably should have done one with a different, oh. All right, 3 pi minus x dx. All right, so the antiderivative of cos is sine, and we've got to do 1 over the coefficient. Oh, this one's interesting. Didn't notice that. Okay, so this is the same as, now it's probably good that we did do this one. All right, negative x plus 3 pi dx. So our coefficient of x is negative 1. Okay, so just be careful of that. So we're going to have 1 over, okay, so 1 over negative 1, so negative 1. So we're going to have negative sine negative x plus 3 pi. And we're going from 0 to pi on 4. All right, so just substituting in pi on 4, first of all, for x. Actually, this question was a good one to do. Minus negative sine negative 0 plus 3 pi. All right, the reason why this question is a good one, because we've got to find out which quadrant we're in. All right, so that's pretty good. You can keep the 3 pi's there, it doesn't really matter. All right, so on your unit circle, we start at 0, here's pi, then we're going to 2 pi. So 3 pi is over here. So just doing 3 pi minus pi on 4, we're in this quadrant. So in this quadrant, sine is actually positive, which is good. So we can do negative sine just pi on 4. And we've got 2 negatives, so it's going to be plus. And then we just got 3 pi. Now, 3 pi is the same spot as pi, so it's just going to be sine pi. All right, so sine pi on 4. Let's just go back up here. Where are we? Oh, no, it's root 2 on 2. That's the one I always remember because sine and cos is the same for that one. All right, so negative root 2 on 2, and sine pi is 0. So we get negative root 2 on 2. All right, again, checking your answer. Let's just put that in quickly. So we're going from 0 to pi on 4. Cos 3 pi minus x dx. Right, and then you got negative root 2 on 2. So this is probably a good one to do also because your answer is a negative and it can be negative. It only has to be positive if you're finding the area under a curve. If you're just doing a definite integral like we're doing here, then your answer is negative. All right, negative root 2 on 2. All right, let's just finish with question 6. And then we'll probably just make this video a half-hour video. All right, so what are we doing? I might have to, I'll just write it down. So we've got y equals 2 plus sine 3x. And then we're going from 0 to 2 pi on 3. And we're finding the exact area enclosed by the curve, the x-axis, and x equals 0 and x equals pi on 3. So we're going from 0 to pi on 3. Now, first of all, we've got to make sure we know whether it's negative or positive. So let's just think about what is actually happening with this sine graph. So we've got a normal sine graph. The 3 changes our period, and the 2 shifts the graph up or down. So actually, before I sketch it, let's just identify those things. So your amplitude is 1. So remember, your amplitude is the coefficient of your trig function. So in this case, it's just 1. Your period of a sine graph is 2 pi on n. So in this case, n is the coefficient of x, which is 3. So 2 pi on 3. And we've had a transformation, so it's gone up 2 units. All right, so when we're sketching it, so your normal sine graph goes from -1 to 1. So this has been shifted up 2. So your your line of symmetry, I probably should say, is at 2. So instead of being at 0, it's at 2. And because your amplitude was 1, we're going from, whoops, not -1, going from 1 to 3. All right, now with your period, it's 2 pi on 3. So this is probably taking you back to when we did trig functions. So 2 pi on 3. And we've got to split it in 4. So we've got our 4 quadrants of our unit circle, so 1 period. All right, so 2 pi on 3, half of that is going to be 2 pi on 6. Half of that is going to be 2 pi on 12. And then here we're going to have 9 pi. Hold on. What are we going to have? 2 pi, 4 pi, 6 pi on 12. Just trying to think if that's right. So 2 pi on 12, 4 pi on 12, 6 pi on 12, 8 pi on 12. All right, so it's a lot easier if you have the same denominator, obviously. So we did that. So if we had a denominator all of 12, so we've got 2 pi on 12. This one is 4 pi on 12. This one is 6, obviously 6 pi on 12. And then we've got 8 pi on 12. All right, so we're going from 0 to pi on 3. So pi on 3 is actually, yeah. All right, so 2 pi on 6 is the same as pi on 3. And our sine graph, oh my gosh. Okay, so a sine graph starts, it is a sine graph, isn't it? Sine graph starts at 0, so it's been shifted up. So it's going to start there at 2. Then our first point goes up, and then it comes back down, goes to here, and then comes back up again. All right, so you will need to know how to sketch sine graphs before your exams. Okay, so we're finding this area in here. So it was from 0 to pi on 3. Okay, so there's our graph. You can see from y equals 2, you've got like that rectangle there. Not that we really need to use that for this one, but sometimes in exams you need to recognize stuff like that. Okay, so we could have done the rectangle and then that other area. But I'm probably complicating things by telling you that. So let's just go back and just shade it all in yellow. All right, so we're finding that area there. So let's set up our definite integral, which we've got up here. We are above the axes, so we're just going from 2 plus sine 3x dx. So that's our definite integral. If we were below the axis, so let's say it had been shifted down 2 units, then obviously we would need to put a negative out the front because we would be below the axis. All right, so I'm just going to rewrite it. What was it? 2 plus sine 3x dx. All right, so we're going, that 2 becomes 2x, so don't forget that's kind of separate to the sine function. And then sine is going to become negative 1 on 3 cos 3x. Forget the bracket. 0 to pi on 3. All right, substituting everything in. So 2 times pi on 3 minus 1/3 cos 3 times pi on 3 minus, and because we've got 2 terms here, I'm going to put them in brackets. Okay, so we've got 2 pi on 3. Those pi's cancel out. So we're going, oops, did I say pi's? The 3's cancel out. Silly me. The 3's cancel out, so we're left with cos pi. So we're going to have minus 1/3. Cos of pi is negative 1. And then we're going to have minus 2 times 0 is 0, minus 1/3. Cos of 0 is 1. So 2 pi on 3 plus 1/3. So we've got 2 negatives here, this negative and this negative, so it turns it into a positive. And then we've got minus 0 minus 1/3 times 1 is 1/3. So we're going to have 2 pi on 3 plus 2 on 3, which gives us 2 pi plus 2 on 3. All right, so just going up, just quickly doing it in the calculator. So 0 to pi on 3, 2 plus sine 3x dx. All right, so again, you can see it separated the fractions, and it's fine to leave it separate like that. The only reason I do that is because it's kind of simplifying it, and it might ask for the answer in that form, but if not, you can leave it as the 2 separate fractions anyway. Did I get the right answer? Yeah, so just thought the denominators were different. All right, so I'm going to leave the video there, just over 30 minutes. Please make sure you have a go at doing the other questions as well, and obviously you can check your answer on the calculator or ask for help in class. Okay, bye.